Hi, we're going to be discussing a problem minimum popping from May Codechef Starters 2021. The problem says that you are given a doubly ended queue or a DEQUEue of size M, that is, it contains M elements, each of which lies between 1 and n inclusive. It also says that each integer between 1 and n occurs in the queue at least once. Now, we want to pop some elements from the front end and the back end of the queue because it's a doubly ended queue, that is, you can pop elements from either of the ends. So we need to find such a method to pop these elements that the set that we obtained of these popped elements contains all numbers from 1 to n at least once. Now let's take a look at the representation of this problem. So this is what a doubly ended queue looks like. You can pop elements from the front end or you can pop elements from the rear end. We've maintained two sets for visualization, front popped and rear popped. So the front popped set contains elements that have been popped from the front. For example, we have popped this one from here. So this one has gone up to that set and has been removed from this doubly ended queue. Similarly, the rear popped contains the elements that have been popped from the rear end of the doubly ended queue. For example, we have popped this 2 over here. So our set can be seen to contain an extra 2 at the end. Now, in terms of the question, the union of these two sets must contain all elements from 1 to n at least once. Now, for this considered example, our m is going to be 7. M is the size of the DEQUEue that is given. So in this case, it is 7 and n is 3 in this case. As you can see, the DEQUEue contains at least one instance of each of the numbers between 1 to n. It contains 1, it contains 2, and it contains 3. So our n this way is 3. Now, a doubly ended queue isn't essentially the easiest data structure to handle. So we are going to look at a simpler array form of representation of this, and we are going to work on that array in our approach as well. So as you can see, this is the corresponding array. How is an array similar to the DEQUEue? Well, in a manner that the removal of a prefix of length x, that is popping x elements from the front end of a doubly ended queue, is equivalent to the removal of a prefix of length x from a corresponding array. Similarly, considering for the rear end, if you pop y elements from the rear end of a doubly ended queue, it is equivalent to removing a suffix of length y from a corresponding array. So this way we can represent the doubly ended queue as an array. Now for the question itself, the problem statement will get converted to something which says that we need to find what prefix and suffix combination we have to remove such that this window of prefix plus suffix contains all elements from 1 to n at least once. Now it is odd to visualize two different segments of an array at two extremities as a window. So we'll just join the two ends of the array for visual representation. So we're representing as a circular array for now. Now removal of this prefix and this suffix from the linear array is similar as removing this entire subarray from the circular array. So this provides us a continuity in visualization. We can view this as a window that we can expand and shrink as per the needs of the algorithm. Now we are going to need this window to contain all elements from 1 to n at least once, as is demanded by the question. We also know that this window consists of prefix and suffix. That means that either the element at index 0 or the element at index m minus 1, m being the size of the array, must be present in the window. Because if they are both not present, then you'll just be removing an odd central part of the array, which is not equivalent to popping in a DEQUEue, because you can't pop the central part of a DEQUEue. That is, you can't pop, let's say, the element at index 1 without popping the element at index 0 first. So that's why we need this continuity. Now that we've established what we need in the window, let us see how we are progressing this window. So the first window that we'll consider is going to start at index 0 because, like I said, we need one of the two extremities to be present in the window, because unless they are present, it won't be a combination of prefix and suffix being removed from the array. So why not start with one of the ends, right? So we start with the index 0. We encounter a 1. So we'll put a 1, denoting that it's a set of numbers that have been popped. So in the set of numbers that have been popped, we have 1 so far. Now we've moved to the next index. We again find a 1. 1 is already in our set, so we don't need to put it in again. We're just keeping track of elements that we already have from between 1 to n, so as to know how many more we need. Now we progress again, and we are at index 2 now, and we encounter the element 2 as well, which is a new element, also an element that we need. So we put 2 in the set as well. We go to index 3, we encounter a 3, and we put a 3 onto the set, and now our set is complete. These are all the 3 numbers that we needed in our set, right? The set of popped elements. So now we end our window at this point because we need the minimum size of the window, right? We need the number of elements that have been popped to be minimum. Since the elements that are being popped are equivalent to the window that is being removed, that's why we need a minimum size of the window as well. So the size of the window is 4. And so we list 4 as our current answer because we don't have anything that is lesser than 4 so far. It is our first attained answer. Now we move on to the next progression of the window. What we'll do in the second iteration is that we can't shrink the window from this side, because what's going to happen is that if we shrink the window from this side, suppose we remove the 0th index, then our window will consist of this 1, 2, and 3, right? That means that our 0th index is excluded as well as our 6th index is excluded. But we just established that one of these two indexes should be present in the window. So we'll not be shrinking it from this end. We'll shrink it from the other end instead. So now we let go of this 3 in our next window. And our window would look something like this, including these 3, that is. Then we'll start to expand our window in this direction, that is towards the direction of the suffix side of the circular array, to find the element that now we are missing in the set. Now, the elements that we had in our set earlier were 1, 2, and 3. Now that we've let go of this 3, we don't have any other 3 in the remaining array that we have selected, that is the window that we have selected. So this 3 has been removed from the set. So now our set is incomplete. So we need to find a 3. Thus, we are expanding it in the other end so that we can find a 3, because expanding it in the same end from which we have shrunk it doesn't make any sense, because we'll end up having the same window as before. Now, when we move behind, we encounter a 2, but we already have a 2, so we don't need to add it again. We again encounter a 2, and then we encounter a 3 finally, which we put into our set again. And so this is the minimum size of the window that we can obtain starting from this index. Now that we've established our window, we'll note its size, which is 6. 6 is greater than 4, obviously, so we won't update the size of our answer yet. Now we'll move on to the next iteration. This time we let go of the index 2 from this, just like we let go of the index 3 previously. So now our array would look like this, consisting of elements up till here. Now, do we need to expand this window like we did in the last iteration? Well, removing this 2 isn't exactly affecting our set, because 1, 2, and 3, as you can see, are still present. Here we have a 2, we have a 1, and we have a 3. So shrinking the window hasn't made our set deficient of any of the 3 values that we need in it. So that's why we don't need to expand it. So we'll just note the size of this window, which is 5. Now 5 is also greater than 4, so we won't update it. Moving on to the next iteration, we let go of index 1 in this case. And again, we are not making it deficit of any of the 2, because removing this 1 still leaves us with this 1. So this is our new window. and its size is 4, which is the same as the previous window, which we had as the answer, this one. So we'll not update the answer again. Now, we have to remove the index 0, but while we do this, we have to take care that index 6 is included. Now, since it is included, we can remove the 0th index. Now, this leaves us with this window up till index 4, right? Extending from 6 to 4, which means that now we're deficit of the element 1 from our set. So we'll move this window 2 steps ahead, because that's where we'll find our first one. And then we'll conclude that this is the final window for this iteration. It consists of 6 elements. So we'll note the size of this window, but it is again greater than 4. So it's definitely not the minimum window that we need. So we won't update the answer again. Now let us think about removing this element. Can we do that or not? If we remove this element, we'd not have either 0 or 6 in our set, because that will leave us with elements 1 all the way to 5. But 6 and 0 have both been removed. We can't do that because we had established that we need one of the two extremities at least to be present in our window. So that's why we won't be removing 6 from our set, and our iterations have finally ended. Now you must be wondering that if we remove 6, what if we remove 6 and then we have to extend this window in this direction to find an element which it made the set deficit of? In that case, we would be including 0. So that window must be a valid, right? Well, not exactly. Because if we're removing this 6 and extending it up to the point 0, then we're reaching the point of the first iteration itself, because we had started our iteration by considering the smallest window starting at 0. So this window, the new window that we'll obtain after the final iteration, would consist of 0. That means it will be starting from the index 0, but it will be either of the size equal to the first iteration or greater, in fact. So it'll lead us to nowhere. That's why we'll not consider that iteration, and we'll end our process at this point. So now we've obtained the final answer, which is 4 in this case. I think that we got an idea of how we are going to approach the problem. Now let us actually look at the algorithm. Since in the code, we'll be actually working with a straight simple array instead of a circular array as we did for understanding the approach better, we'll be starting our iteration, let's say with an integer I, which moves in this forward direction, and j, which moves in this backward direction for selecting a suffix. Now our first step is going to be to select such a prefix that contains all of the 3 numbers that are included in our n. So that means 1, 2, and 3. Now, as we traverse the array, we realize that here is a 1 and another 1, then a 2 and a 3. This completes our set that we need. So we stop our I at this point. So our I is now at index 3. This is our first window. Now for our second window, as we have noted, its size to be 4. The first window size to be 4. Now for our second window, we will exclude this 3 from here. And we decrement our I by 1 as well, because we've excluded the 3. So our I comes over here instead of here. Now we have 1, 1, and 2 in our set, but we've removed a 3, the only 3 that we had. So now we need another element 3. We look for it in the suffix, because like I said, moving in the prefix again makes no sense. You'll end up right where you started. So now we'll start decrementing the j. So we iterate through the last element, which is 2. We don't need a 2, but we'll have to include it, because in the suffix, we do need the last element, obviously, otherwise it won't be the suffix. Then you can remove this 5, and then you can remove this 3. By removing, I mean you're including it in your suffix. So now we've found a 3 that completes our set of 1, 2, 3. And so our j now is at this point. The total number of elements that we have selected are 1, 2, 3 from the suffix and 1, 2, 3 from the prefix. So that means 6. But out of 4 and 6, obviously 6 is greater. So that means we can just not consider that 6 and have 4 as our answer. Now we'll move our I to another element on the left. That means we'll exclude this 2 as well. And so now our I is not at this point, but instead it is at this point. Oh, I over here. Now, the only 2 that we had, we've removed from the prefix. But was that the only 2 we had in the window? Well, no, we had these 2's as well. So our window hasn't been made deficit of any of the elements that we needed. That means we can consider this to be our window for this iteration. So that consists of the first 2 elements and the last 3 elements. So it is of size 5, but 5 is again greater compared to 4, which means we can disregard 5 as well. Let us continue the dry run and make our I equal to this now. We've removed a 1, but we already have a 1 in the prefix itself. So again, we haven't made a deficit of anything. That means our size now is 4, which is the same as this. So we can disregard either of the 2. I'll just disregard the new one. Continuing it, now our I is just not there at all. We're not considering any prefix at all. So we've removed this 0. We since have one of the extremities present in our considered window, so we are still fine. Now we have a 2, 2, and 3, but we don't have a 1 anymore. That means that we need to get a 1 starting from this suffix. So what we can do is that we had this 2, we had this 2, and we had this 3. Now we need a 1. So that means we'll go for this 2, 3, I'm sorry, another 2. We still haven't obtained a 1, and now we obtain a 1. So now our set is complete. We have 1, 2, and 3 all, and our length is going to be 6. Now 6 is greater than the previous 4 that we had, so we'll disregard this 6, and 4 will be our final answer, because now we cannot decrement j and bring it over here, because that will mean excluding this index, and then we'll just be removing something from the center of the array, which is not equivalent to popping from either of the ends of a doubly ended queue. So we end our process at this point, and we're left with the answer 4. So this was the dry run of the algorithm. Moving on to the code. Okay, so let's try to understand this. M here is the size of our array, and n is the number which from 1 to n you're going to need in your list of popped elements. So in this case, n is 3, as per our example that we've been considering, and m is 7. We also declare an array to keep track of the frequencies of all the elements in our window to ensure that whichever element from 1 to n becomes 0 in frequency, we'll look for that element from the suffix side, like we explained. So we traverse it from 0 to m and take in the element. So let's dry run it correspondingly. Now we are saying that whenever the frequency is 0, ind will be updated to I. Now ind is the variable that is keeping track of the first time that you obtained the final element that you needed from 1 to n in the first window. So the first window starts from 0. And so if occur is 0, which in fact it is for the first element that we took in, which is 1. So occur of 1 is 0. Since it is 0, we update index. So since index is already 0, it won't really affect it. So we'll just leave it as it is, and we increment the frequency. So the frequency is incremented. Then we take in the second element and we do the same. Now frequency of 1 isn't 0 anymore, so we don't need to update index, but its frequency does need to be updated to 2. Then we take in 2, its frequency is 0, so we update ind to its index, which is 2, and we update the frequency of 2 to 1. Then we take in 3, 3's frequency is also 0, so we'll update it to 3, which is the index of 3 here, which is the index of 3. Its index was 2, this index was 0 and 1. So these are not the numbers that we're updating, these are the indices. And so we make the frequency of 3 1 as well. Then we again encounter another 3. Its frequency is not 0, so we'll not update the index, but we'll make this 2. Then we encounter a 2. The frequency will be updated, but it's not 0, so nothing will happen to index. Then another 2. So this frequency will become 3. Now our end value is 3, and we are only finding the frequency in occur, that is, we are only storing the frequencies of elements in our window. So our window ended at index 3. This is our window. But in occur, we have the frequencies of elements up to the end. So what we'll do is from after index to the end, we'll decrement these frequencies that we had incremented previously. So we'll decrement 3 by 1 and 2 by 2. That means its frequency will become 1, and 3's frequency will become 1 as well. So now these are the frequencies of the elements in our window. Ans becomes ind plus 1, which means 4, which as you'll see is correct. It is the size of our first window. So this is where we decremented the frequencies of the ones that were not included in our window from ind plus 1. Then the next step is to exclude elements. So starting from end, we'll exclude elements from the prefix, and this is for including the elements from the suffix. So first of all, let us decrement this frequency as per the first step. So the frequency of 3, that is, we are eliminating 3 from our prefix, and the frequency of 3 is going to be decremented. So now this is 0. Now we are taking some steps when it is 0, because we do need every number in our window. So when the frequency of the number in our window becomes 0, we are going to start decrementing the variable that is keeping track of the suffix index. So our j is keeping track of the suffix index. It was initially over here. So our suffix starts from here. And as long as we don't find the element that is missing, we will keep on decrementing our j and updating frequencies of those elements that we encounter on the way. So we encounter 2. So 2 will be updated. Its frequency will be 2 now, because this suffix is also part of our window now. This suffix is also part of our window. Then our j moves to here. Since we again haven't encountered 3, this will be updated. The frequency of 2 will be updated to 3, but nothing further would be done. That means we won't stop the loop. We'll move ahead. So now we've encountered a 3, and so its frequency has become 1. We're making its frequency 1 over here, and we are out of the while loop already. Now we have our required suffix. So this is the required suffix. And from our prefix, we ended our prefix over here. So it is from 0 to this point. Our prefix has 3 elements, and our suffix has also 3 elements. So here we update our answer as minimum of ans, which initially was 4, and 6, which we have found just now, prefix plus suffix. This gives us the prefix plus suffix. So 4 and 6, we'll select 4 and discard 6. So this loop keeps running this way, and it runs so until we have reached a point where our prefix is no longer there. That means only suffix is considered for the window, and then we stop our iteration and print the answer. So now, as is evident, the part of 2 windows that is going to overlap, that means our first window was from here to here. This was our first window. And our second window was up till here. So this part was overlapping. This part, it was overlapping in the 2 windows. But did we have to traverse it twice? No, we just decremented this, and we already had the frequencies of the remaining elements. So we are not required to traverse any window twice. So that means the entire array elements we are traversing just once. So that makes the complexity of this program to be big O of M, M being the size of the array. And that's about it. Thank you.